Okay, so for this last one, to see if we have a minimum value for f, should probably check to see what is happening with f prime, because this is going to tell us whether it's going to increase or decrease. So we are potentially going to use sign analysis, where we find some critical points. So let's first take a look at f prime. If f is x times ln of x, we're going to have to look at f prime of x. Product rule here, derivative of x is 1 times ln of x plus x, no derivative, times the derivative of ln of x, which is 1 over x. If you can see x times 1 over x, these x's cancel, so you're left with ln of x plus 1. So maybe not even looking too much at the analysis of the sign chart, but let's just look at what this graph looks like. The derivative of f prime is x ln of x plus 1. So let's think about this. Ln of x looks like this. It has a key point at 1, 0, and natural log looks like this. Has an asymptote right here, but it has this, and then it moves up like that. So ln of x plus 1 is just going to have a critical point 1 movement up, and it's just going to have the same shape but moved up exactly 1. This goes down forever still. Never touches this. This is an asymptote. So if you can look, ln of x plus 1 will equal 0, okay, at this place right here. So there is a value, we'll just call it c, where f prime equals 0, okay? That indeed would make f horizontal there, and we could potentially have a minimum or a maximum there, depending on what's happening in the graph here. So think about what's happening before and after. If I draw this again, I'm going to try this a little bit bigger. So this is at 0, c. Here's what the graph looks like. Okay? So since this is f prime, to the right of f prime is, or to the right of c, f prime is positive. It's above the x-axis. But to the left of c, f prime is negative. So basically what's happening, to the left of c, f prime is negative, to the right, f prime is positive. So that means f is going from decreasing to increasing. Okay? So basically what's happening is f goes from decreasing to increasing. This is going to be a relative min. So what I see here is that I will have a relative minimum here. So that one's wrong. It does have a minimum value. What I'm going to have to do is I'm going to have to look and find when f prime is equal to 0. So I'm going to have to set this equal to 0. That's going to happen when ln of x is equal to negative 1. And if you remember your log rules, this is going to be ln of x equals negative 1 when e to the negative 1 equals x. So if you forget what rule I just used, that rule looks like this. I don't like red, green. So the rule is this. When you have log base b of x, and that equals a, you can rewrite this as b raised to the a, and then move x to that side. So what I did ln of x equals -1, ln is basically log base e of x. So then I rearrange this so that it's e to the -1 equals x. So that's what I just did there. E to the -1 is just 1 over e. Okay? So don't get confused. That's not going to be the answer here, or maybe it is. But what I need to do is I need to plug in x equals 1 over e back into the minimum to find the minimum value. Because when it's asking for what is the minimum value, I'm asking what is f. So f of 1 over e is equal to 1 over e times ln of 1 over e. Now there's a few ways to write this. I know that ln of 1 over e is the same thing as e to the -1. So maybe I should have just kept it like this. But the -1 can be brought to the front, and so this would become -1 over e ln of e. Then ln of e is equal to 1, so I'm just going to get -1 over e. So the answer, the minimum, is, this is the minimum value of f. And it happens at x equals 1 over e.